What's up, 8th grade? Mr. Agnos here. This video is for topic 2-4. And in this topic, we learn that equations sometimes don't only have just one solution, right? X doesn't always equal 5. There's other possibilities. We can have equations that are broken. They have no solution. There's no number that when you plug it in, you get a nice, true mathematical statement. And we can have equations that have infinite solutions, where you can plug in any number you want, and you're going to get a true mathematical statement. So let's take a look. All right, I'm just going to use a regular old blackboard today. The first type of equation I'm going to do is one that you're used to. Okay, this is a two-step equation. 2x plus 4 is equal to 10. No big deal, right? And I'm just going to go ahead and solve this really quick. I'm going to subtract 4 from both sides. Those cancel. I get 2x is equal to 6. And my last step would be to divide 2x by 2, divide 6 by 2, and I get x is equal to 3. Okay, what that means is 3 is the only number that you can plug back into the original equation and get what is called a true statement. I'll show you what I mean. So I'm going to rewrite this pink equation, except instead of x right here, I'm going to plug in 3. Right? That's our answer. I'm still going to add 4, and that is going to equal 10. All right, so because 3 is the solution, I should get a mathematically true statement. 2 times 3 is 6. 6 plus 4 is 10. So on the left-hand side of my equal sign, I have 10, and you can think of that as $10 or 10 pounds. On the right-hand side, I have 10, and again, you can think of that as $10 or 10 pounds. And this is true, right? This is a balanced scale, a balanced equation. So that's what it means to have one solution, and this is what you guys are used to. But it turns out there's other possibilities. All right, I'm going to write another equation up here. Let's see. This one's a little messier looking. It looks more like what we've been working on. That's a G. The book, oh boy. The book wants me to use a G here, so I'm going to use a G. 2G plus 4. So you guys can see that we're going to have to distribute here, all right? And then I have 6G plus 9 on the other side. All right, let's take a look at this equation. All right, you guys know that I'm going to have to distribute here on the left-hand side. I'm going to have to multiply 2G by 3 and 4 by 3. So 3 times 2G. All right, if I have 2G plus 2G plus 2G, right? That's what to multiply by 3 means, right? It's repeated addition. So 3 times 2 would be 6 G's, right? If I have 2 G's and I multiply that 3 times, then I have 6 G's. I still have my plus, and then 3 times 4 is 12. And on the right-hand side, we have done nothing. Okay, so now we have an equation. I can't make a 9. All right, now we have an equation with variables on both sides, and this should look a little suspicious to you. I have 6 G's on the left and 6 G's on the right. So I'm going to go ahead and subtract 6G from both sides. I'm going to subtract 6G from the left-hand side, and I'm going to subtract 6G from the right-hand side. All right, if I have 6 G's, I take away 6 G's. I have no G's left. I'm left with just 12. And on the right-hand side, I have 6 G's, but I take away 6 G's. So I have no G's left on the right-hand side, but I still have the number 9. Okay, take a look at this. 12 equals 9. This is not true, right? $12 does not equal $9. 12 pounds does not weigh the same as 9 pounds. So the way we show that is by drawing a little line through the equal sign. We say 12 does not equal 9. This is what is called a false statement. It is not true. It is false, right? This is called a false statement. And anytime we're solving an equation and we end up with a false statement, our original equation right here has no solution. There's no number that I can plug into that original equation that is going to give me a balanced equation. Remember how in the last problem I got 10 equals 10? There's no number. I have infinite numbers to choose from, right? There's no number that I'm going to plug into this and it's going to work. And I think you can kind of see that if you look at the blue equation. The blue equation kind of gives you some intuition as to why that's true. Look at the blue equation. I have 6 g's here and 6 g's here. So those are worth exactly the same. But then I'm adding a different amount to each of them. So I'm taking something that's the same, and I'm adding a different amount to each. There's no way that's ever going to be equal, right? It's like if I had a $5 bill in my left hand and a $5 bill in my right hand. Okay, those are equal. But then I add a different amount of money to each hand. There's no way that's ever going to be equal, right? It's permanently off balance. It's like a scale. All right, I'm going to draw a little scale here. Here's the stand, and they usually have something like this, and then I have a chain going down, and we have a little plate here, and I got a chain going down, and I got a little plate here. And do you see how it's not equal? It's like it's broken. It's like there's something wrong here. This is cracked. That little blue line is a crack. This scale is permanently out of balance. So this is a type of equation that has no solution. And so the way that you write the answer is you just write no solution, or you just click on the box that says no solution. There's no number that's going to work here. Okay, let's take a look at one more type of problem. Let's see. 9 plus, this time they have me using p's. 9 plus, let me see how much time I have left in this video. Oh, I still got 8 minutes. All right. 9 plus 4p minus 2 is equal to p plus 3p plus 7. P plus 3p plus 7. Okay, so there's a lot going on here. On the left-hand side, I have 9 right here, but then I'm taking away 2 over here. So even though there's a 4 p's in the middle, I can still combine like terms between this 9 and this 2. Again, imagine a table. I got a table of fruit, and I have 9, these are bananas. I got 9 bananas over here, and I have 2, I take away 2 bananas over here, and I got some apples in the middle, right? Well, it doesn't matter that there's some apples in the middle. I can still take these bananas on the right-hand side and combine them with those bananas over here, right? And I can still say, okay, I got all my bananas over here, and I got no more bananas over here, right? We're just we have something in the middle that we have to work around. All right, so this is a positive 9. So imagine that that you have $9. All right, but then you loan me $2. All right, so how many dollars do you have left? Well, if you had 9 and you loaned me 2, so you got rid of 2, that means you only have 7. All right, 9 minus 2 gives me a 7. And then I still have my 4p. And then on the right-hand side, I have a single p right here. I'm adding 3 more p's, so that's 4p. And I'm adding 7 on the right-hand side. Okay, this should look really suspicious to you right here because I have the exact same thing on the left-hand side as I have on the right-hand side. Addition is commutative. That means it doesn't matter if I write 2 plus 3 or 3 plus 2, right? Those are both equal to 5. So over here on the left-hand side, I could rewrite that as 4p plus 7, right? I just switched the order just like I did over here. And that is equal to 4p plus 7. Okay, so I got p's on both sides. Let's subtract 4p from both sides. All right, this is how we would solve an equation with variables on both sides. I have 4p's, I take away 4p's, there's nothing left, and I still have my 7. On the right-hand side, I have 4p's, I take away 4p's, so I have no p's left, and I have 7. All right, so last time I got what was called a false statement. I got 12 equals 9. That is not true. This time I got what is called a true statement. 7 does equal 7. Right? This is called a true statement. $7 equals $7. 7 pounds equals 7 pounds. 7 miles equals 7 miles. So this is what we call a true statement. It is always true. 7 always equals 7. So this type of equation, when you end up with a true statement, is going to have an infinite number of solutions. I'm using, this is the symbol for infinity, right? An 8 on its side. Infinite number of solutions. What that means is you can literally go to the number line, close your eyes, pick any number you want, plug it into this equation, and you're going to get a balanced equation, a balanced scale. And I think you can see that really by looking at this line right here. I have the exact same thing on both sides of my equal sign. So it doesn't matter what number I pick. If I pick 1, for example, I'll have 4 times 1 plus 7 is equal to 4 times 1 plus 7, right? Everywhere that I had an x, I plugged in a 1. Well, 4 times 1 is just 4, right? So I end up with 4 plus 7 on both sides, which is just 11 equals 11. And this same situation will happen no matter what number I pick here, whether I pick 2 or 3 or 5 or even negatives or even decimals. I'm always going to end up with a true statement. Okay, so let me kind of try and synthesize this here in the closing minutes. I got 3 minutes left. All right, if you end up with, x equals some number, right? X equals some number. This is one solution. If you end up with a false statement, so I'll say 7 equals -2, right? This is a false statement. If you end up with something like this, this is no solution, right? There's no, the scale's broken. It's never going to balance, right? There's one solution over here, right? X equals 5, X equals 10, whatever. If you get a false statement, this is no solution, and I didn't leave myself a lot of room here, but if you end up with a true statement, 12 equals 12, right? This is called a true statement. If you end up with something like this, I'm out of room there, I'm just going to put ... then you have infinite solutions. That means any number will work. All right, these types of problems are kind of weird in the beginning, simply because you haven't seen them before. Oh boy, I'm all blurry. But I think you'll see once you start working with them, they're not that big a deal. Okay, hit me up in class if you have questions, and I'll talk to you soon.